Thank you, Admir. So, welcome to this year's edition of Hardcore PKI. So, what does Hardcore PKI mean? I got that question since people were afraid that I would, tear the head of chicken or something on the stage. But it's not going to be that bad. So I'm probably going to be less hardcore than David Hook. But anyhow. So Hardcore PKI is on recurring theme during Tech Days here. So we had it for 2015, 16, 17, and 18. And basically, it's a summary of kind of the last year, what I think has been hardcore in our daily work, so to say. And, well, I'm not going to bore you too much with a recap of previous years, but we had things like a lot of options to be able to configure, things like, okay, how do you put an end-to-end solution with PKI or signatures together from edge to cloud, things like that, to how to maintain the full stack of a deployment from operating system to HSMs, etc. So, but those you can you can read up on it on the internet, I guess. So what do I think has been hardcore PKI during 2018? Well, this is my short agenda and my new hardcore hard rocker. So crypto agility is a hot thing, which is pretty hardcore. We have had a lot more hardcore work with HSMs and PKCS11 than we've had before. So I'm going to talk a little bit about that. And then, of course, there's a lot of discussions around how to be able to use PKI and signing easily in all, for example, new use cases like IoT, but also old use cases like AI does, etc. So let's get right to it and start with the crypto agility. So, and what is hardcore with that? So we have a historic past which has been nice and dandy, very comfortable, very stable. The things we have seen changing are like SHA-1 to SHA-2, and now upcoming is SHA-3, but still RSA algorithms. So it's the same base, same cryptography, just a new OID that you want to use SHA-256 with RSA instead of SHA-1 with RSA. And we also had EDD Si. That was hardcore when it came in its days, but it was around for a long time before it came into use. And but now it's kind of used heavily for a number of years, so we're starting to feel comfortable with this as well. And things that might change is that there are some new curves coming now and then. It's pretty much, well, it's still just a new OID in the certificate, and the basic signatures or signature calculations are the same, at least from my perspective. I'm not 100% sure that David agrees, but I think it's been fairly stable. The only issue with EDD Si is that SCEP is still used, and it's fair to say that SCEP and EDD Si does not play together. But then we have some new things like EST, and CMP works great with EDD Si. So we've been living in a pretty comfortable world, and standards have evolved slowly. The crypto standards, standards for certificates, the messaging, the digital signatures, the protocols, some new OIDs, upgrade from SHA-2, upcoming SHA-3. Not so hardcore, actually. We know how to do that. But so in the future, which is a lot more rapid than it has been before. So we have EDD Si, which people want to use. So it's used in a lot of contexts already, but not in PKI, I would say. So that's coming. There's customer requests for things like the SM2, SM3, and SM4 that David mentioned, Chinese algorithms. We already have some support for Ghost and Russian algorithms, although we don't ship to anyone in Russia, as far as I know, today. But anyhow, so there's requests for that, and then, of course, this looming post-quantum thing. So there's a lot of demand for faster turnaround. So it doesn't, in the future, people expect it to be a lot faster to, say, introduce EDD Si or SM2, 3, 4, and SHA-3. Then, I mean, it took like 10 years to switch from SHA-1 to SHA-256. That's not going to cut it in the future. So the standards around crypto is coming faster. The certificates, new OIDs for everything here, digital signatures, of course, and protocols and messages. Well, there's going to be more change, and it's expected to be more rapid. So, but we are all here for the details, right? So, what are the details around trying to be crypto agile with EDD Si and Sign Server, or products like EDD Si or Sign Server? I think I can generalize a little bit. So this is the, say, EDD Si and Sign Server crypto stack. It's like an onion. So it's a square onion in this case, but you can imagine it round. So there's all these different layers that somehow are involved in crypto. Actually, there's the hardware. Okay, maybe not super much involved, but there's the operating system. There's our famous Java VM, which is upgrading or not upgrading. We have EDD Si and Sign Server, which are Java applications. We have Bouncy Castle in the middle, which we rely heavily on for all these things that I mentioned. And then we also have an HSM. So there's plenty of layers in this onion. And while it looks easy on the surface, it's, well, let's just move to SHA-3, or why can't we just use EDD Si instead of ECD Si? Once you start to peel this onion, you see that there are stuff to do on all these layers in the onion, which makes it tricky. So more details. So this is an example of a call thread then to say, I want to make a signature with SHA-256 with the RSA, just to make it simple. So it goes to EDD Si, a Sign Server, which uses Bouncy Castle. Oh, okay. So we also have the notion of crypto token, but we can ignore that almost. So it goes to Bouncy Castle to do the messaging, parsing, ASM1 encoding, etc., depending on exactly what we want to sign. And then it goes down, if it's software crypto, it goes down to Bouncy Castle. If it's a hardware crypto using an HSM, it goes to Java PKI S11 provider, or soon the P11NG, as Marcus is working on. Then it goes to the HSM's P11 library, and finally to the HSM. So and all of these steps are, of course, involved in switching from SHA-2 to SHA-3. There has been a lot of work to do things more agile. I mean, Bouncy Castle has worked pretty nicely over many years to make the API very agile. So this is my mandatory code slide, where you can see, okay, I want to make a digital signature with Bouncy Castle. So I pass in a signature algorithm to the left to say, okay, I want to use SHA-3 with RSA, or SHA-3 with EDD Si, or what it's going to be called. And then I say what crypto provider I want to use. If it's soft keys, let's Bouncy Castle handle the crypto. If it's an HSM used, we pass in a Sun PKI S11 provider. And then we also, of course, if we want to make a signature, we need a private key, which are the real private key bits in case of software crypto again, or a reference, a PKI S11 reference in the case of an HSM. So in this aspect, the API is super agile, I would say. We can just change these three parameters, which are easily configurable, and bam, we have done a signature with a new algorithm. Could be a post-quantum, whatever. We don't have to change the code of EDD Si or a Sign Server. We just have to change, the parameters to these calls. So the APIs are pretty agile in themselves. But the modifications we need to do, of course, we need to modify EDD Si Sign Server or similar applications to take new parameters or configure new parameters, whatever. Bouncy Castle has to, of course, implement new algorithms or new IDs, depending on exactly what's to be done. In case of HSMs, we have to patch, typically, Java, PKCS11, because Java won't, or at least historically, have not updated their PKCS11 support very fast. So if you want to do something in Java 8, which is still the most common production Java version, and we want to do EDD Si or post-quantum, whatever, if it will work through P11, we would definitely have to patch Java for it. And of course, the HSM, that was one of the questions I wanted to ask Dieter yesterday. So when will post-quantum algorithms be possible to use through PKCS11? I don't think it's not part of the standard, so it definitely needs some tweaking. And of course, the standards have to be settled first, otherwise we can make a signature that no one else can verify. We don't want that, so you need interoperability. So for a quick example, real-world example, so to say, when I implemented support for SHA-3 256 with RSA in EDD Si, it took like 2 hours if you use software crypto, which means Bouncy Castle. So that's pretty easy. Of course, to a large extent because it's RSA. But if to do it on an HSM, it will not be so easy. Then I have to modify the Java P11. I need to find an updated P11 library of the HSM that supports SHA-3 256, etc. And then there are, of course, always looming dooms like Java serialization. So if you happen to Java serialize an object in any place, then once you try to do something which Java 8 doesn't support, it will fail on you very hard. So better decode it as byte arrays and send it over the line instead of trying to serialize things. And of course, if that wasn't enough, we also have GUI changes to make. So if someone actually going to change our use of new updated crypto algorithms, we need to change the GUI as well. So currently in EDD Si, and similar in Sign Server, we have 19 different options of digital signature algorithm, and we have currently 68 options for different key sizes in RSA, different elliptic curves to generate when you want to generate the key. So that's, well, adding options to that. We'll come back to that a little bit more as well. So the current status, so to say, is that agile crypto is hot on the agenda. It's a hot topic of the agenda, but we're not quite there yet. So we will hear a lot more later from Tomislav, how this can be implemented in the future, or today as well, in agile way. But I say for general purpose applications, we're not quite there yet, and we have to get our hands dirty, so to say, and do some coding, and we have to work on with our hands in the ground for the coming years in order to improve the agility of crypto through the whole stack, the whole onion, so to say, to get to a dream scenario where you can plug in a new support for a new algorithm and it shows up nice and dandy and you can start using it right away without recoding your application. The next topic on my list are new HSMs, it says, but it's more maybe, well, it is actually. So some examples, or no, first a slight introduction. So also on the HSM world, we have been living in a very comfortable world. So I think we've even written it like in our documentation that in HSM we support PKCS11. So basically any HSM with a good support for PKCS11, you can plug it in and EDD Si and Sign Server will make use of it and it works. And that has actually been the fact for years and years, almost decades. It's been very comfortable, but not so much any longer. So what's happening now on the HSMs and PKCS11? We have to tear our hair and see what is going on. So some real-world examples. Amazon Web Services, they have a cloud HSM which does PKCS11, but it doesn't do PKCS11 like everyone else. So, well, of course, you're very hopeful. Just put EDD Si and Sign Server on AWS, spin up a machine, connect the cloud HSM, pay the $2 an hour to have it running, and damn, it doesn't work. So then you have to get down to places where you haven't been for 15 years and put your hands in C code and try to figure out, okay, how can we get this thing to work? Azure and Google, they don't even use PKCS11 for their cloud HSMs. They have REST APIs, different REST APIs even, as I've been told, even if they would be similar. So we can't just plug and play HSMs anymore. We have to code. And as I kind of hinted yesterday, as a developer, I'm lazy. I don't want to write new code. I want to copy and paste something. And sorry, I can't do that. And then there are also newcomers on the HSM market. So, and then, well, it's pretty similar like the AWS Cloud HSM P11. Typically, the first implementations are not like the old stable ones like Utamac or Thales or SafeNet, where has been stable HSM with full support for years. So it just works. So it's kind of new implementations, and you have to fix test cycles. And there's even new concepts, being put out on conferences and papers like software multi-party encryption, as good as hardware security, and things like that. Things we haven't started looking at yet, but it's you can hear about it in different places. So from being a kind of soft and nice HSM world, PKCS11 have become, at least for me, hardcore with C programming, which I realize that I don't like it anymore. And the final, we have also the last question, which is ease of use. Everyone wants PKI and signing to be very easy to use. You need it because everyone can't be a PKI expert, and everyone shouldn't be a PKI expert. You should be able to use our stuff without having to go to PrimeKey school for 2 years. And here we'll go straight into the details and some examples where it's actually not so easy to make it easy to use because the users are fighting us. No, of course not. But some examples where you need stuff. For example, there's new things. Every year there are new things. So new options come, but old options are never removed because someone needs it. So how do you think, or how do you make things easier to use when you every year have to add new things? Then you have to, well, somehow, work with you guys and community to see how can we make an increasingly complex world easier to use. It's a slight contradiction. I have 2 examples here. One is OCSP, which also has been nice and comfortable standard RFC 6960 for years, or the previous one, 2560. But then we start figuring out that, okay, when there is an error or a bad request coming into an OCSP responder, maybe for both DDoS reasons or for cryptanalysis reasons, we don't want the OCSP responder to sign everything with its private key just for a bad request, which is specified in the standard, by the way, that it should do. But we can return an HTTP 401 instead. I mean, if you send a bad request, why shouldn't you just get a quick HTTP error? So we need an option for that. And of course, the old options are still needed because people want to operate in a standard compliant way, but some want to operate in a, say, new lightweight error mode. The same with qualified certificates. We have the screenshot here, shows the current options for a qualified certificate statement, which is without the PSD2, new PSD2 additions. But PSD2 comes with new options. So configuring a qualified certificate statement, it's not easy. and I'm not sure I know how to make it easy, because all the options are needed, because every trust service provider will need different values in all those fields almost. So what do we mean by ease of use? Is it PKI for dummies, or is it giving a decent capability for experts like yourself to do your job more as efficiently as possible? Is it nice GUIs? Is it new nice REST APIs in order to hide all the PKI, at least when you use it, so no one sees it? Easy to install, easy to configure and audit, or you just want to embed and hide it? Or probably it's something like all of the above, I think. So what do we have to do to not have to be neo when configuring or using our PKI? So there's a lot of things, and of course, for different people and different organizations, easy to use means different things. So for some, it's easy to install. For some other, it's nicer, easier to use GUI. For some, it's just remove all the clicking from my day job, so to say. And for some, it's give me a REST API, which is much easier to integrate with than a CMP. And of course, there's some steps we're taking, which Marcus and Michael has already mentioned. Delivery forms to make it easier to install, configuration audit things like state dump and config dump. The GUI topics are hot on Mike's and Marcus's list, but yeah, we're gonna probably need some help to, what are the best options. Integration, embedding, REST API. Even I was a bit skeptic there as well. Comes back to that all the time. I'm such a lazy developer, so I don't want to develop a new API. But when I started playing with the nice Swagger UIs for the REST APIs, even I was quickly convinced that this is the future of easy-to-use APIs, at least, or integration APIs. My short conclusions for hardcore PKI 2018 is that crypto agility is desired, and it's hot on a lot of people's list, but currently the stack is too deep, or the onion has too many layers, and each layer is slightly too complex or not agile enough, so to say. So we want to go there, but we're not quite there yet. And some very old, reliable standards which we've been living comfortable with for years or even 10 years are starting to show age, and we need to see, okay, how will this work in the future? Maybe REST APIs for HSM is the future and not PKCS 11. We will see. We don't know today either. And the last one is that we add to the complexity every year, but we don't remove anything. But of course, still we want to have easier systems to use. So that contradiction or dilemma is something we have to try to work on, which is also, well, it's hardcore. And that was Hardcore PKI 2018. And we want to, of course, know your needs for the different topics, ease of use, agile, and things like that.
What kind of shoes do you have there?
Oh, those are rock climbing shoes. It's La Sportiva Futura, if you want to know the details.
Looks funny. Well, anyhow, I have a kind of a introductory question. So what about the hardcore stuff from 2017? Has it become softcore, or how would I call it? Is it easy now? Is it trivial?
Well, I guess it's...
Or do we just add layers and layers to your onions of complexity?
Well, I would say different people have figured out slightly easier ways to do it, at least. There's still the complexity of the stack from 2017 is still hard, and you have to update everything. But there's, people are using Puppet to automate it, including updating the operating system and things like that. And of course, we have the cloud or the appliance has been working hard to make full stack updates easier. So there are different tools which are coming to, say, popular use at least. So there's a lot of, I think, depending, it doesn't matter if you use software or appliance or cloud, there's people are working to make that easier. And there are tools to do it, so I think that's somewhat being worked on very nicely.
And then somebody was funny and posted the question, so what do you think will be hardcore for 2019?
Well, I did have an Outlook slide, but I removed that. I didn't dare. So I'm gonna keep that. Or let's see if actually I have it here.
Funny secret. Also, please raise your hand so I can see you for your questions.
So you talked about agile PKI and the stack being too deep and that we're not quite there yet. I'm curious what role PrimeKey intends to play in helping solve that problem for the world.
Good question. So we're, of course, we're working on and looking to what we can do more with people like Tomas Gustavsson from ISG, who has been researching crypto agility to see what models we can fit in. We've also, an example is that we were looking for making a master's thesis, investigating, what exactly are the things in on this onion that you need to consider to make it more agile over the whole onion, so you at least have a well-defined, okay, this is what we need to do to make it more agile. So those are two concrete steps that we are working on.
Do you have any sense on how quickly these problems need to be solved before it'll be too late?
No, very hard to say. I mean, we can still be, since everyone is working so hard, for example, on PQ, which would be the kind of looming death, but everyone is working quite hard on that. So at least parts of the stack, like from the HSMs to Bouncy Castle, are working very hard to be agile and be ahead of time. And so in that aspect, as long as we can kind of keep, even if we have to do coding to get there, we can do coding a little bit ahead of time, so we don't have to do it in the last second. So that's the current hope.
He said, short-lived keys.
Oh yeah, okay, exactly. That's
yeah. Well, short-lived keys, I think, is a good mitigator to our impending doom.
Yeah.
I was going to ask you a question, or a rhetorical question, but we see Acme being adopted across a number of products. I know you're working on Acme support as well. There is not currently an API for administration of CAs for things like, creating a new sub-CA and publishing CRLs and revoking and listing and things like that. Is PrimeKey looking at maybe participating in defining a standard based on its experience with these things that's in the same spirit of Acme, a sister spec maybe? Mm-hmm.
Yeah, it's great. Yeah, well, actually, that has been on our minds. So with the REST API, which is more modular, so we can add new modules to it, and I think Mike mentioned yesterday, so administration aspects are one of the additions to REST APIs that we are looking at, and definitely it has always been my, it's been my vision for a quite a number of years to be able to standardize some of these aspects, because we don't have, as you say, any standardized management APIs yet. There's a lot of standardized enrollment APIs, kind of, but not the management stuff that you want. So that's, I love that.
Oh, more work to do. Great. So thank you, Thomas. But we're not going to give you a Raspberry Pi.